Welcome to Tackett's House of Horsepower. It's me, Steve Tackett, and decisions have been made. Big decisions have been made. So, there's no turning back now. We're doing it. So, after last week's video, I got a lot of messages and comments and information pouring in, pouring in. And it seems like a lot of you really want to see a 400 on boost, turbo 400, not the transmission turbo 400, an engine turboed 400. So that's what we're gonna do, and we've made the decision. So we're gonna see what we can do with a 2-bolt main 400. And I know we've all heard, don't use 400s, they're weak, they're thin, they overheat, not good for boost, this, that, everything. That's what everyone says. And maybe they're right. But screw it. We're going to do it anyways. And see. We're going to put it to the test. What if it's awesome? What if we can get this to work? And we're going to do it old school. Blow through carb, 400 small block. I know. It might be reckless, but we're going to do it. And hopefully it's going to be great. And we're going to prove all the naysayers wrong. Or we're gonna scatter a lot of parts. I don't know. It could go either way. All right, so I guess I'll start by showing you what I did this week. I picked this guy up. It's a VSR 88 millimeter turbo. I picked this up from a coworker of mine who I've been talking to for a little bit about turbos. He's a turbo guy. He's an all right dude for a Mustang guy. But big thank you to Shay. He gave me a really good deal on this. Basically, I couldn't say no. And it is used, but he said it only had about 30 minutes on it. And I believe him because it is like brand new. There's no movement, there's no play in it. It feels good. And if you look inside, there isn't even any soot or hold on, let me pull this off. Well, look, it is a divided flange. I guess that helps with spooling it. It hits the fan blades and directs it in 2 different spots, and it makes it do the spinny thing faster, I guess. I don't know. He did neck it down. It's a 4-inch. He necked it down. So I might take this off and redo it so I can keep it all 4-inch, possibly. But yeah, we have a turbo. And it's basically brand new. And he sent me the information on it. I'll tell Sarah to go ahead and put it in right here so you guys can see. I'm going to try and show you exactly what parts we're using, exactly how much it costs, and that kind of stuff. A lot of times people just, a lot of these videos, they don't show all that. So I'm going to show you exactly what it is, part numbers, costs, and stuff like that whenever I can. So look down in those blades. I mean, it looks brand new inside and out. And plus, I know Shay at work. He would not buy junk. So anyway, I got a good deal on it. Really good deal, actually. And that's what we're doing. That's why I say there's no turning back now. So, we have the turbo. Now, we have to build something to bolt it onto. So, first of all, I just want to say it's like 80 degrees out right now. It's a little overcast. It's but it's perfect. The weather has been great. Last couple days, I'll take this for August, summer in August, 80 degrees. I'm loving it. So suck on that, Art, over at Veteran Revivals. He's my homeboy back in Arizona. He's got a YouTube channel. Check him out. He's doing a C10 build right now. He's actually swapping frames and he's pulling a body off, and he's dying. It's like 120 degrees back in Phoenix right now. So check him out. Say hi. Tell him Steve said hi, and send him some of this weather. He'll appreciate that. Anyways, here's the victim. We discussed this last week. Just kind of did an overview of what we're dealing with, and the candidate is we're going cubic inch. Why? There's no replacement for displacement, but displacement, you're moving as much air as you can. To move that much air, you're gonna help the turbo spool up and do turbo-y things. You know, the more air you can move, the better. This is just a big air compressor, and the bigger your air compressor is, the more air and fuel you can shove into it, the more power you're gonna make. But the Small Block 400 does have some weaknesses. With that big giant stroke, I have some complaints. If I could go back in time and talk to the Chevrolet engineers back when this engine was being drawn up on the drawing board, why would you go with a big stroke and a shorter connecting rod? You're asking for trouble. So a lot of the rumors and speculation about this engine not being a good engine is because of the failures that it would have, the overheating that it would have. And a lot of that is the way people tune their engines. But you can't get over the dynamics of the engine, being that it has such a large stroke and such a short connecting rod. What ends up happening is, we talked about this last week, rod angle. And what does that mean? When the crankshaft is in top dead center and bottom dead center, the connecting rod is straight. Okay? Now picture the crankshaft at the halfway point. At the halfway point, that connecting rod is going to be kicked over at a pretty steep angle, right? Now, under power, the more that angle gets, the less force you're putting on the crankshaft, and the more force you're putting on the connecting rod and the piston, the thrust side of the piston, the skirt against the cylinder wall. It's a bad idea. So, in order to give this engine its best chance at survival, you want to decrease that rod angle as much as possible. There's two ways to do it. Reduce the stroke, so the points at the center, you know, the halfway point, top of the center, bottom of the center, if you reduce that by putting a 350 crankshaft in a 400 block, you make a 377. Well, that's going to be a big bore with a short stroke. So you reduce the rod angle, you lose a little bit of cubic inches. Let's clarify this. I've seen people make this mistake in some forums and stuff. Anyways, rod length has nothing to do with cubic inches. Nothing. The only thing that dictates cubic inches is stroke and bore. That's it. Connecting rod could be as long as you could make the connecting rod 3 feet long. You don't increase cubic inches. You don't change the cubic inches at all. So reducing the stroke, which means the two midpoints are going to be closer together. So the rod will be straighter in the bore. The straighter in the bore, the more force is being applied directly to the crankshaft instead of the side wall of the piston, the block, the connecting rod's trying to snap in half. So some people mentioned in the comments last week that we should go 377, and that's not a bad idea. It's not a bad idea, because if you put a long rod, say a 5.7 rod or even a 6-inch rod on a 350 crank and put it in a 400 block, that thing will scream. It will scream. And I'm still kicking around that idea, but I kind of sold this as a 406, 400 build, 406 build, 30 over 400, 406. So it's kind of my thing. So we're not going to give up any cubic inches. So, but how can we reduce the rod angle? Well, the other method is a longer rod. So that's where we ran into problems last week with those pistons. Those pistons, the dish in them is really, really ridiculously low. The dish is really low. They used a 5.56 rod with a 400 crank. Is just not conducive to make horsepower. I just don't do it. Like that is the worst case scenario. You're getting the biggest stroke with the shortest rod and trying to put power to it. You're gonna break the rod, you're gonna break the piston, the cylinder walls are pretty thin in a 400. So you want to decrease that pressure against the sidewall as much as you can, or at least mitigate it as much as you can. So that being said, we're gonna keep it a 400, I think, unless somebody can convince me otherwise in the real near future. We're gonna keep it a 400. We are gonna spend the money though and get a good crankshaft. We're gonna get good rods, and we're gonna get new pistons. Those pistons, I do not want to use them. There is a possibility you could use a 5.56 400 piston with a 5.7 rod and a 350 crank, and you can get the rod length longer, and you can use those pistons and it'll be a 377, but because you reduce the stroke, you would also reduce the compression, because the static compression is dictated by the volume of the cylinder, and by reducing the stroke, you reduce the volume of the cylinder, so therefore the compression ratio would be even lower. Did you write that down? Did you write all that down? This is what goes in my head all the time. This is what it sounds like in my head. So if you use those pistons, those really nice pistons, on a 5.7 rod and a 350 crank, and you get spacer bearings, you can make a 377, use those pistons, but you're gonna drop the compression even lower, which would put us down around 7-to-1. And that's just too low. That is old school thinking. And that's how they did blown engines, root style blown engines back in the day. They'd slap a 671 or 871 and they'd have to drop the compression way down, whatever, I don't know. So the pistons just aren't gonna work. It's just, we're kicking a dead horse trying, honestly. So I need to order pistons. I might as well order 30 over, and we might as well bore and hone the block. So we have a fresh bore, fresh hone, new pistons. We're gonna get the compression ratio up. Now this is where some discussion has gone back and forth with my coworker at work, my buddy Jason, this and that. Everyone agrees to get the compression ratio up. There's some speculation though of how high should we go. 10-to-1. My coworker says 10.5-to-1. My buddy Jason says keep it a little safer, around 9.5. So what does that mean? Getting the static compression ratio down. I want to build a rowdy but mildish rowdy small block, and then put the turbo on it. So this thing should make a decent number by itself. So the 10.5-to-1 would make it a pretty healthy 400. But I don't want to have to run race gas. I want to run this thing on pump gas as much as I can. When I go to a big race or something, maybe I'll throw VP 110. The gas station down the street from my house, literally down the street right here, sells VP 110 at the pump. So I can get VP 110 like walking distance from me. So I'm not too worried about that. Regular pump gas around here is 93 octane. It's pretty good. So I think I'm gonna shoot for like 9.5. You know, maybe 10, maybe 9 out of 10. We'll find a midpoint. Okay, so rod length 5.7 minimum. 5.7 minimum, unless I can find a good deal on pistons that'll take a 6-inch rod. That would be the way to go. The problem is I don't like those pistons where they have to move the wrist pin up so high that it gets into the oil ring and stuff like that. I don't like those kind of deals. So I want a piston that'll get me around 9.5 to 10-ish without getting the wrist pin up into the oil ring. So I'm on the hunt. I'm looking. I gotta find a crank, rods, pistons, rings. I'm gonna get some severe duty bearings, and we gotta get this block prepped for the machine shop. That's the next question. I need a local machine shop somewhere here in Tennessee that can bore it, hone it, and balance it. If you want something like this to survive, especially the longer the stroke. Remember, the longer the stroke, the more, I'm not gonna say it's more important than a shorter stroke, but it is kind of, you're more susceptible to throwing a rod or having an issue with the engine not being balanced, the bigger the stroke, right? So it's critical. If you're gonna try to build a 400 to survive, rod angle, step 1. Step 2, balanced. It has to be balanced within 0.5 gram if you can. So I need a good machine shop that can bore, hone, balance, because I'm gonna buy a crank, rods, pistons, and I'm gonna take all of this stuff, flex plate, harmonic balancer, the entire rotating assembly. You take the entire rotating assembly to the machine shop and you want them to balance it, all of it. So I'm looking for that. Also, we're gonna deck the block. The deck on these four, I asked my buddy Jason, 20 thousandths is a lot, 25 and up, like the block is stock. It's never been touched. So the deck heights are pretty high. So I want to get that down a little bit. Also, if you're running an MLS gasket, well, we're gonna run aluminum heads, we're gonna run an MLS gasket. They want the surface of this to be so many microns smooth-ish. So you're not gonna just slap an old Felpro gasket on it and go. I want this to survive. I don't want to blow head gaskets. So a fresh deck, smooth deck with a good MLS gasket is gonna give us the best chance of not blowing a head gasket. And basically what we're doing is what I call buying insurance. There is no absolutes. I mean, when you're building horsepower, you're gonna have risk. So running a 400 is a risk. You can mitigate the risk by decreasing rod angle. So we're gonna spend some money on rods. Blowing head gaskets, we're gonna throw boost at it. It's important. A nitrous motor or a boost, you wanna get a good head gasket and you want a good seal. So we're gonna buy insurance by having it decked. So I call it buying insurance. Does that mean we're never gonna blow a head gasket? I mean, no, but you can mitigate it as much as possible by doing that. Are we never gonna throw a rod? Hopefully, but it's, again, if you can get that rod angle down, you're buying insurance. So that's the way I rationalize it in my head. So we need to prep this block for the machine shop, and I'll show you the things that I do to get a block ready to go to the machine shop, because that's going to be where it's headed. So we'll go through that this weekend, and yeah, I'm excited. This is new territory for me. I'm learning a lot. I'm asking a lot of questions. I'm hearing feedback from you guys. It's great. Like I'm just a home build guy. So I build pretty fast cars, but I do it myself. I do it on my own. I do it by thinking things through and asking the right questions and knowing some good people. And it's, you know, this is exciting for me because it's new territory. I've never done it. I have never owned a car on boost. So we're learning as we go. So let's get this block ready for the machine shop. I'm gonna show you everything that I check and all the things that I do before anything goes to the machine shop. And this week we need to sit down and order pistons, rods, crank, rings, bearings, gaskets. And I gotta be real nice to Sarah so she'll let me spend the money, you know. I'll take her to dinner or something, you know. Schmooze her a little bit. I'm working on it, okay? So let's get this apart and get it prepped for the machine shop. Okay, so right off the bat, a couple things I'm looking at. I don't like to use these pressed in plugs, oil galley plugs. I want to take these out, and then I want to run an NPT tap in here and tap it for a plug. I like to put plugs in these just because when you run a high volume pump and stuff and you spin this thing up really high, these things can pop out. It's not very common, but it can happen, and that would be really bad. If you lose one of these plugs, your oil pressure will immediately go to zero, and yeah, you'd have a big issue on your hands. It would be really terrible to lose the engine because of a 10-cent little plug popped out. So I like to tap these to an NPT plug. And you don't want to do any cutting and grinding and tapping and drilling and stuff like that on an engine after it goes to the machine shop. So I do this type of stuff before it goes to the machine shop, because that way, once they clean the block and I clean the block when it gets back, the chances of metal shavings being in there, you know, it's better to do it now. So the other thing you'll notice is this engine had a double roller timing chain. And I don't know if you guys have ever had this problem before, but sometimes double roller timing chains like to hit the block right there. You see that little shiny spot, the witness mark? That witness mark is made by the gear. So they had a double roller timing chain on it. They didn't check their clearances, and this thing was hitting the block. So I like to grind this down a little bit. I take this lip off. Take this lip off, and you'll have a lot more clearance. I like to run a billet style double roller. That's fine. But I like to get the ones that have the bearing that sit against this surface here. And I don't want it touching here. I want it to hit here, not here. So there's a little bit of grinding we need to do there. Some tapping we're gonna do here and here and here. Also, I just noticed that we have a broken bolt. That's great. So maybe we'll try and get that out. Again, you don't wanna be drilling and tapping and grinding on an engine that just, a fresh engine from the machine shop, and then you're gonna start tapping on it. No, don't do that. I mean, you can, but you better make damn sure there's no metal shavings inside the motor. So, like I said, it's just safer to do it now. Also, I'm gonna get rid of these freeze plugs. I don't like steel freeze plugs. They rust. So we're gonna put brass in it. We're gonna get rid of these. So I'm gonna get all the freeze plugs out. I need to get the crank out. I did stick this piston in. We'll pop that out real quick. And yeah, take the crank out, yeah. So then I think it'll be ready to go to the machine shop. All right, let me get this one piston I stuck in here. I didn't like torque it or anything. I just stuck it in. I don't really know what to do with these. I got these pistons, rods, bearings. I've got all this stuff here, and I'm not going to use it. I don't know if I'm going to stick it on Marketplace or what. It sucks because this is Somebody spent money and got good rod bolts and put brass bushings, full floating. I don't. They spent some money, but they spent the money on stuff they shouldn't have. Well, come on. So let me get the piston out, take the crank out, and we'll start on freeze plugs, I guess. All right. Piston's out of the way. Let's yank this crank out of here. Check this out. I found a note. Balanced by Tri-City Competition Service. There's a date. 5/15/92. Wow. Well, that's pretty, it survived. It survived a pretty long time. That's crazy. Yeah. Nice job. Whoever, is that his? Breckenridge, Breckenridge, Michigan, 48615. I wonder if they're still around. Anybody up in Michigan know if this place is still around? Another thing I noticed about the crankshaft is all the bearings I took out are stamped on the back, and you can see the STD, these are standard. So the mains are standard and the rods are standard. So that is a standard crankshaft. I wonder if that's the original crank for this engine, and it was rebuilt at some point and balanced at some point, and it's dated from 1992. So either it was built and never ran ever, or well, I don't know. It's always a mystery, you know, digging through engines, taking it apart, trying to figure out the story behind it, you know, like where it came. It was up in Michigan. I bought it in Arizona. So, and now I'm in Tennessee. So this thing's been around. This thing's got a little story behind it, I guess. One more thing I like to check real quick is I take something straight edge and I run it. I set it on the main journal back here, the thrust bearing journal, and I slide it back and see if it hits. This one does. If a 400 is ever line bored, then this lip for the rear main seal will not be standing up proud. So if this is standing up higher than the we got pupper dogs. They're loose. Anyways, they're gonna go check on Miss Barbara. So anyway, what was I saying? Okay, if this block was ever line bored, then the lip for the remain seal will not be sticking up proud. So in this case, it hits. So that tells me the block has never been line bored, it's never been bored and honed, and it's never been decked. So this block is a virgin. Basically, it's untouched. So that's good. I'm kind of a survivor, I guess. I mean, to be in this kind of shape, I checked run out. It had almost no run out. Basically straight 4.5 thou total piston to wall clearance. I mean, the block, it's amazing actually. I don't know how it must have had no miles on it. It must have came out of a truck or something, a full-size car, and it just didn't have any miles on it. So who knows? Anyway, let me finish taking. Next, I'm gonna start on these freeze plugs, I guess. But yeah, so why is that? Oh, I forgot to tell you. Why is that important? Well, when you order your gaskets, you need to make sure you get the right rear main seal. If it's been line bored, you need one that's got a little different notch in it so it fits the block better. Otherwise, you're gonna have leaks. So you need to know before you order your gaskets what you got. All right, we'll set these main caps back on so we don't get them lost. I should have mentioned this before, but mine were already numbered. I don't know if you can see that, probably not. But right here it says 1, 2, 3, 4. Can you see it? So it matters. The arrow, there's always an arrow. The arrow points forward and they're in the right number. These things are, they're cast and then they're machined on the block. And so they have to go back in the same spot, in the same direction, exactly where they came from. You don't want to be shuffling those around. So main caps and rods, they're machined together, so they have to go back where they came from. So I set the main caps back on. I'm just gonna set the nuts and washers on it real quick so they don't get lost. There is a direction on them. The chamfer side always goes down. So off topic, but this week we buried Ozzy Osbourne. Can you believe that? Any Ozzy Osbourne fans out there? I was a huge Ozzy Osbourne and Black Sabbath fan. I am a huge Ozzy and Black Sabbath fan. I guess we're getting old. But we're losing people left and right. Growed up with, What kind of music do you guys listen to? I like classic rock, obviously. Ozzy, Black Sabbath, Led Zeppelin, all that kind of stuff. But I was also in high school in the 90s, so I was into metal, Metallica, Pantera, Slayer, you know, big Alice in Chains fan. Also, I'm secretly a big Primus fan. I love Primus. I follow them pretty close. I like their new drummer. Anyways, I build cars. I also like music, you know? All right, let's start knocking freeze plugs out. And you don't have to do this. You don't have to knock these freeze plugs out. But I have gotten engine blocks back from the machine shop, and somebody, probably some minimum wage guy in the back, he just knocked them in. He just knocked them all in and then threw it in the parts washer and let it wash. I want this thing to be as clean as possible when I get it back. So I want these out of here. I don't want them knocked in and then it doesn't get a good circulation through the inside. I want it to be all washed out as clean as possible. I don't want them floating around in there and then I got to dig them out later. So I just got in the habit of completely stripping it before it goes to the machine shop, just because I've like I said, I've gotten it back from the machine shop and there was freeze plugs floating around inside the block, and I can't stand that. It's just lazy. So I'm gonna take them all out so they don't have to, and that way I can ensure the block gets really good and clean. There's no obstructions floating around inside there, you know what I mean? So let me knock those out real quick. It started drizzling on me. I had to move the motorcycles back in. So now I'm out here getting wet. But basically, the way I do this is I try to knock it sideways and then turn it, grab it with some vice grips and try to pop it out. Sometimes you can just get lucky and go like this. Done. One down. Let me show you something. Fun facts about 400s. One is they're the only small block with 3 freeze plugs on the side. It's the only one. Some of them don't have the middle one drilled, but it'll have the boss. The boss will be here, but the hole won't be there. And one of those down there had it. But anyways, this one has all 3. So it's the only small block, 3 freeze plugs. It's also the only small block that is a Siamese bore. So the cylinders are connected in the middle between all cylinders. All the cylinders are connected. So 350s, 327s, 307, 305, 283, 265, all the other small blocks, you would see a gap right here. And water can flow completely around the cylinders, right? On a 400, it cannot. It's called a Siamese block. It's the only small block that has that. So anyways, fun facts. Let me get these out. I'm about to get rained on, I think. I'm just going around knocking all the freeze plugs out, right? And I just want to stop real quick and show you how clean it is. Look inside the casting down in there. Look at how clean it is. This might be the cleanest. This might be the cleanest small block, original small block I've ever seen. Like, how is it so clean? It's been ran before because the freeze plugs are rusty. Like, but I mean, it is really clean in there. I can't believe it. That might be the cleanest 400 I've ever seen, especially standard, everything stock, untouched, cleanest 400 I've ever seen. Okay, we're cruising right along. Freeze plugs are out. Next, I want to get these oil galley plugs out. And the way they do it at the shop is they take the plugs out of the back, they use a long rod, and they knock them out. But I'm not doing that. So what I'm gonna do is put a little tiny hole in it, screw a screw into that, and then yank them. So I'll get those popped out, and then we're gonna tap those. Hopefully you just pull that right on out of there. First one came right out. It's surprising how easily they pull out. So 60, 70, 80 pounds of oil pressure behind that. I mean, it's amazing. More of them don't pop out while the engine's running. But yeah, quick and easy way to get them out. Wow, that one came out really easy. So yeah, I don't, in a stock engine, yeah, these work fine probably. But anything performance, I try to get rid of them. Just buying insurance, you know what I mean? Just buying insurance. Maybe it'll never happen. Maybe it'll happen just once. But that little guy right there could cost you your whole engine. You know what I mean? Think about it. All right, so we got the old plugs out. Now what I want to do is get it ready for the new NPT style plugs. So I'm going to run a quarter inch NPT tap into that hole. And I don't want to go too deep. I just want this plug to get in there and go just a little bit past flush. So you don't need to tap this thing in there a mile. You know, you just far enough to get this guy in there just past the deck height here, and call it a day. I get it started, go in a little ways, and then back it out. And then check it. I don't think I took any metal off yet, so it's not going to start yet. But I do this back and forth because I don't want to go too far. So that's about it right there. I just went in just past the deck here. So you don't need to go any further. It's nice and tight. It's an NPT thread, so it's not going to back out. It ain't going to fall out. It doesn't matter how much oil pressure I put to that. It ain't going nowhere. Okay. So we end up with something like that. See there? We're buying insurance. That's it. Just buying a little bit of insurance. Now, I did mention this earlier. You can see where it was hitting right here. I want to take this lip off. I grind this down a little bit right here. Just take a grinder and smooth that edge and take that down a little bit. I know it's a problem. If I get a billet timing chain set, I know it's going to hit there. So I want to do all my cutting and grinding and drilling and tapping and anything that's going to create metal shavings or any kind of metal working. I want to do as much of that now before it goes to the machine shop. That's all I'm doing. I know it looks like a lock, but it wasn't. I just kind of rounded it and smoothed it a little bit because I know if it's going to hit, that's where it's going to hit. So that was kind of like a preemptive strike, you know, just kind of, if there's going to be a problem, it's going to be right there. So you might as well just do it now. Okay, I pulled those plugs back out because I like to disassemble everything as much as I possibly can. Like oil filter, adapter, anything, plugs, things like that. Take them out. Freeze plugs, take them out. I just like to do that because I'm afraid that the minimum wage guys working at the back of the machine shop there, are they really going to take as much time and disassemble and clean and stuff as much as I will, and inspect as much as I will? I don't know. Maybe some will, maybe some won't. But again, disassemble everything you can. That way it's going to be the best chances of everything getting washed and cleaned and, you know, ready to go. So the block is ready to go to the machine shop, in my opinion. So I need to order all the parts. As soon as the parts get here, this can go to the machine shop with the other parts when they get here. So that's about as far as I can go with this. Now, last week, this came up in the comments. I mentioned the top end of the engine, okay? Now, the top end of the engine is going to be these track ones. I got a set of track ones. Well, anyways, you get the idea. Take a look at these track ones. They have been ran before, but not much. Look at how clean they are. There's no carbon. Other than the oil, you would not even know that this was ever on an engine. So these are like brand new track ones. Okay. The track ones, I believe, we'd have to look it up. I'll double check. But I think they are 220 intake runners. So let's see what happens. I want to see what gaskets. I got a set of 1206s. We'll start here. Let's see what the 1206 looks like on these ports. And then we're going to take a look at the intake manifold. We're going to talk about that for a second. It came up last week. I just want to walk through it myself and then get your guys' feedback. Okay, so I think these should be pretty close. A 1206 Fel-Pro should be pretty close. And they are. That's not bad, actually. That's really not bad. I'm just checking the fitment, okay? Now, I said last week that I want to gasket match the intake manifold. And a couple people got on the comments and was like, oh, you don't need to. It's a waste of time. You're only going to get 5 horsepower if you do that. It's not needed. It's not necessary with boost. Okay. You might be right. You might be right. Forced induction doesn't care as much as an NA build will. You know, the way the ports match up, and you want a good transition right here. But it may not be worth that much horsepower, but take a look at this intake. Here, I'll show you. Okay, take a look at the cylinder head, and then take a look at the intake manifold. It doesn't look like it, but they're very different in size. Let me lay the gasket on here and you'll see. All right, now if I take my gasket and I lay it on here, you'll really see the difference. Look at that. Now, is that worth messing with? Maybe you're right. It's only 5 horsepower, 10 horsepower, sure. But what about this? Is it possible that if you go from a much smaller opening to a big opening, am I going to create a lot of turbulent air right here? As it comes off of the smaller port into the bigger port, could that create a lot of turbulent air? And my gut is telling me yes. So is it worth fixing? In my opinion, yes. Look at that port. Not a lot. I don't want to take a lot out of it. But it seems to me like I could clean that up decently and just get a good smooth transition, just because of the turbulent air. I don't know. Maybe it's only 5 horsepower. Maybe you guys are right. But my OCD won't let me leave that alone. I think it'll drive me crazy. Like, I can't even look at it. I have to fix it. So, I don't know. This might be next week's project. It's not going to be exciting because porting sucks. So, I don't know. I think I should just at least do a gasket match on it. I'm not going to try and port it all the way through both sides. You know, I just want to get it the same size as the gasket. So that's where we're at with the Turbo 400 build. It sounds like I'm talking about the transmission. People are going to click on this video thinking I'm talking about building transmissions. I'm building a Turbo 400. It's a 400 that's turboed. Anyways, that's where we're at with it. I think the block is good. I'm actually really amazed how clean it is. That thing is, wow. So the block is great. I need to order a crank rods, pistons, rings, bearings, gaskets. If Sarah doesn't lose her mind when she sees the price, I'll get those stuff ordered up this week. When those parts get here, that can go to the machine shop. In the meantime, I think I need to do some work to that intake and the gaskets, and the transition needs to be smooth. What are you guys' opinions? I mean, there were some people last week that said that was a waste of time and effort and stupid. Maybe it is stupid. In my opinion, in my head, I'm picturing a not smooth transition and the air wanting to get real out of control. So, what do you think? Am I wasting my time? Is this a bad idea? I don't know. Maybe the whole thing's a bad idea. But anyways, that's where we're at. That's what we're doing. There we go. And that's some good advice if you're taking an engine to a machine shop. Those are the things that I like to do, even if it's just a stock 350. Like, that's the kind of stuff that I'm doing before it even goes to the machine shop. So hopefully you got some advice out of that, I guess. I don't know. Let me know. Tell me what you think. And please hit like, comment, subscribe, all those things. Don't forget about our website. Sarah made that. And those t-shirts. She made those. So, and we need to sell a lot of them so I can afford the parts to put this together. And so anyway, let me know what you think. Give me a comment. I like to hear from you guys. And we have an email, we have a P.O. box, we have all that stuff. So check it out. She'll put it in the description probably. I think. I don't know. I'm just the guy that talks to himself in the garage. She does everything else. I don't know. So that's where we're at. Hope you guys have a good week. And till next time, see ya.